What if I told you, one of the greatest cosmic discoveries isn't billions of light years away in a distant galaxy, but just 6 light years from Earth? A star so ancient, it predates our sun, a frozen planet orbiting it, and a mystery that could reshape our search for alien life. Today, we journey to one of the oldest stars in our cosmic neighborhood, Barnard's star, and unveil the secrets of its long-awaited planet, Barnard B. And by the end of this video, you'll see how this lonely, frozen world could help us uncover a galaxy full of hidden Earth-like planets. Barnard's star might not be the brightest light in the night sky. In fact, you can't see it without a telescope. But in the grand cosmic map, it's a record breaker. At just 6 light years away, it's the closest single star to our sun. And it's old, incredibly old, likely over twice the age of our sun. Born before Earth existed, before the dinosaurs roamed, Barnard's star is a cosmic survivor, quietly drifting through space for over 10 billion years. But for all its quietness, astronomers have obsessed over it for more than a century, hoping to find something orbiting it, something that could change everything. Since the early 20th century, astronomers suspected a planet might orbit Barnard's star. Strange wobbles in the star's motion suggested a hidden companion, but time and time again, those claims fell apart. For decades, the planet remained a phantom, until 2018, when an international team of astronomers, using one of the most precise methods known, the radial velocity technique, detected the unmistakable pull of a small planet. It wasn't a gas giant, it wasn't a hot Jupiter, it was a superearth. A rocky planet, roughly 3.2 times the mass of Earth, orbiting close to its ancient star. Finally, after a century of failed searches, Barnard B was real. So what is Barnard B? Let's take a closer look. This planet orbits Barnard's star at about 0.4 astronomical units, a little closer than Mercury is to our sun. But don't let that fool you. Barnard's star is a cold, dim red dwarf, so despite its close orbit, Barnard B is a frozen world. Temperatures on its surface? A chilling -170 degrees Celsius. That's colder than Pluto. A land of ice, rock, and eternal darkness. But here's the exciting part, even in this icy wasteland, there could be subsurface oceans, hidden beneath miles of ice. And if so, life could still find a way. You might be wondering, with over 5,000 exoplanets catalogued, why should we care about Barnard B? Well, first, proximity. It's one of the closest exoplanets ever discovered. At just 6 light years away, it's practically a neighbor by cosmic standards. Second, it's a low-mass superearth. Most nearby exoplanets are gas giants, but Barnard B is rocky, like Earth, with the potential for complex geology and atmosphere in its past. Third, its extreme age. At over 10 billion years, Barnard B is older than Earth, the Moon, and probably life itself on our planet. It offers a unique chance to study how rocky worlds form and survive over the lifetime of the universe. Now, let's address the big question: could there be life on Barnard B? On the surface? Probably not. It's far too cold. But beneath its icy crust, conditions might resemble the subsurface oceans of Europa or Enceladus, 2 icy moons in our own solar system where astrobiologists believe life could exist. Imagine an ancient ocean, warmed by the planet's core, isolated for billions of years. Primitive microbial life, surviving in the dark. It's a long shot, but one worth exploring. Because if life could arise on a frozen planet orbiting an ancient star, it could be everywhere. So how do we learn more? Right now, Barnard B can only be detected indirectly, through its gravitational tug on its star. But with the upcoming James Webb Space Telescope and powerful ground-based observatories like the Extremely Large Telescope, ELT, we may soon be able to directly observe its atmosphere, its surface temperature, even its chemical composition. Imagine detecting water vapor, or even biosignatures, on a planet orbiting our second closest star. And beyond Barnard B, this discovery encourages us to search more red dwarfs, stars once dismissed as unlikely hosts for life. The nearby systems of Proxima Centauri, TRAPPIST-1, and Luton's star are next in line. The discovery of Barnard B isn't just about one planet. It's about what it represents. It reminds us that the universe is filled with rocky worlds, orbiting dim stars, hiding in plain sight. That even the most ancient, quiet corners of the galaxy could harbor surprises. It expands our definition of a potentially habitable world. Life doesn't need a bright sun and warm oceans. It might survive in ice-covered seas, deep underground, or in conditions we can barely imagine. And as we continue this cosmic search, Barnard B stands as a symbol, proof that discovery is always just around the corner. In the vast, dark ocean of space, we've barely dipped our toes in the cosmic shallows. But each new discovery, each distant planet, each ancient star, brings us closer to understanding our place in the universe. Barnard B is more than a frozen world. It's a stepping stone. A neighbor waiting for us to say hello. And who knows, in the icy dark beneath its crust, something might be waiting. If you loved this journey to Barnard's star, hit that like button, subscribe for more cosmic mysteries, and share this with your fellow stargazers. Until next time, keep looking up.